Hey, what is going on, guys? I'm Mario and welcome back to another video tutorial. Today we have two interesting examples. Both of them are cylindrical and there are from questions that we had is how to, let's say, do detailing in an area like this and do proper topology, and also what topology would look like in a object like this. This is what we're going to cover today, so let's begin. All right, let's begin with the first example, and I'm going to use a cylinder, and I think 28 sides, it's going to be fine. The sides will actually depend on the number of, let's say, number of factors. If you don't plan to do any detail, if you do not plan to do any booleans, so you can use even 16, 20, 24. 24, 28 sides are some kind of a golden middle, I would say, if you still plan to do some detailing and you want to have enough geometry. But the thing is, if you go too high, so let's say 32 or 36 or something like that, then if you plan to do some kind of, let's say, early shape block out, or let's say even booleans in our case, it may be too dense, so it can also become hard to control. So it's just going to be that finding the golden middle, because with cylinders it's always going to be tricky. So for now we're just going to use 28 size, and I think that it's going to be just fine. So this is, I think, fine. We can add one cut here, and we can also add chamfer here. So basically this shape is not that difficult if, for example, wouldn't be that chamfer at the bottom. So if we need to do, let's say, a small cut here in the middle, we would just use something like this, use a fill hole, and we immediately get the shape what we need. Since we have this chamfer at the very bottom, this makes it a bit tricky simply because we need to do the cuts all the way down. So if I now just increase this maybe a bit like that, and we need to have cuts all the way, which actually cuts through this area as well. So this is what sometimes can make a topology look a bit tricky. So there are a couple of ways to do this. One is by using a multi-cut, and the second is by using booleans. So for example, if I just use, I can actually show you the difference between the two. So we have the symmetry on. I can go to one of the side views, and I'm gonna just decide on which edge I'm gonna cut. So I'm gonna, let's say, cut on this one to here, hold shift just to have it a bit more straight like that. And there we go. So I think that should be the cut that we need. So yeah, so let's I just want to make sure that I do a straight cut here. All right, and the other way would be if you would go to your object mode and then select the cube. And now with the cube, you basically need to do the same cut, but you just now need to reposition it. So let's say something like here, and if we now do the cuts, now we might have an extra geometry to work with. So it's again going to be the balance between the two, what works for you in this case. But I just went for multi-cut. In many situations, I will just go with the multi-cut. So let me just delete this part. We're gonna delete these parts, and we're gonna delete these parts. There is an extra cube here. And now we just need to bridge this, and bridge this. And if you just want to make sure that everything is super straight, you can use scale and just scale it into place. So now you're gonna know that it's super straight. So that's one thing. And yeah, so let's just close this part here as well. And what we can do is just slide this up to create a small curve, something like that. And now what we should do is just clean this up a bit. So let's close this area at the bottom, and I'm gonna just extrude it a bit more inside so I have more area to work. All right, and now we have a small triangle here, but it's not that big of a deal for now. So I'll just slide it for now here to the top. All right, and the thing is we cannot remove this edge simply because it's our structure, and basically this point is holding the shape of a circle. So we are trying to hold that. The only thing that may be a problem is that since this is a circle and this is slowly transitioning into a flat surface, and this point can affect that, so we're gonna see how that works later. But first, let's just close some of the points here. So we need a middle here, so I'm just going to use connect components to close this, and we need to do the same thing. So we have here 1, 2, 3. So let's close this as well, connect components, and one edge loop in the middle, which creates this thing, and same thing here at the bottom. So we need a couple of these. Connect components, and connect components. Same thing at the bottom. All right, so the next thing what we need to do is just make sure that we have enough topology to work. So we're gonna need a couple of edge loops here. We're gonna need one here. We're definitely gonna need some edge loops here, but because we have a triangle, our flow goes in the wrong direction. So we're gonna need to redirect that here to the middle, delete this. I'm gonna need one more loop here and one more loop here. So again, the thing is they are all flowing not the way we want. So we're gonna need to redirect these. And I'm gonna see later how this performs, because we now have one triangle here and one triangle here. So we're gonna see later how to deal with that. And I think for now that might do. So let's try and add a bevel to this area, this knot. And with the bevel, I just need to be careful that I don't have any edges going into other edges that might create strange deformation. But for now, I think all looks fine. I just wanna see without the wireframe. So we have small pinching here, but again, that's because we have this triangle here. So maybe I can just slide this to the side a bit. But we're gonna deal with that soon. All right, so there are a couple of ways now we can deal with this triangle, is just connect this to here and remove this point. And then we're gonna have something like this. So there is going to be some minor pinching here, and depends now what we want to do to remove. So basically what is happening is you will see that this triangle is actually going to be on your curve, and this is what's causing the pinching. So ideally what we want to do is put this triangle on a support loop, because basically support loop will do the stretching and then this triangle will be below that. So to do support loop, we can just select this part, turn the chamfer on and do it like this, but you can notice that we have some strange thing going on, and the alternative would be that we create one manually like this. So this is now our support loop, and basically this edge should then go here. And now it's looking a bit messy, but you'll see that once we remove some edges here, that it should be a bit more clear what we did. So now you can notice that this, what was before on the very edge, now has a support loop. And it's now less of a pinching in that area. All right, so now if you wish, you can still clean this up a bit, but I think it's just fine for now. And we can now add one more loop here on the top. So this is going to be that extra support loop, and it's just giving a bit more cleaner result there. All right, so there's still, if you still see a small, so this is now very small pinching here that we can also test with a blend to see how it performs, and we can also maybe see how that actually works. with maybe darker color. So it's very, very small pinching here. And this is basically just because you have these two edges close. And basically this area is what's causing this small pinching here. So if you really want to remove that, you can also, let's say, remove this edge. You can also remove this edge. Actually, I don't want to remove all of it. I just want to remove this part, and then you have a bit more simplified geometry where you connect it like this. And again, it might be a bit cleaner. So that is one way. And there is here at the top. Let's just close that as well. And as for the curve here, you can now control it simply by adding more divisions here. And there we are. So it's looking fairly good, I would say. All right, and now as for the final thing, if you want to do the circle, that's why I mentioned maybe I didn't need it to actually work on this part. So if you want to create a circle here, we just use circle-less components. Let's put it to auto and radial offset. And I just want to twist this a bit. All right, so let's say something like that, and simply extrude. And we're gonna need the support loop here as well. And so now we have something like that. So basically, yeah, this is going to be our first example. So I'm just gonna hide that. Let's turn the grid back on, and let's now talk about our second example. All right, so let's continue with the second example, and let's again use the same cylinders. So I think 28 sides might be enough. If you want maybe sharper details, you might want to try with 32, but I think 28 will do. And also one thing maybe I forgot to mention, why 28, 32, 24, so why intervals of 4? Well, basically, if you would, let's say, work on 1/4, it's just going to be then easier to translate that on the rest of the cylinder. So if we now change this to something like, let's say, 20, not 25, but maybe 26, it's still an even number, but you notice that only one axis actually covers the edge while others don't. So again, that means that we can work only on 1/2. And if you need something in the middle, if you basically need to, let's say, work in symmetry, it's going to be hard on one side. So if we keep it in intervals of 4, it's just going to be easier to work with. All right, so what we can do here is I can do one extrusion. So this is going to be our inner cylinder, and actually I can select all of this, invert selection, delete, and just bring it maybe a bit more down, and then we can work from the top. All right, so some of the solutions that were presented were based on sliding the edge, meaning that we would have a support loop. So I'll just turn symmetry on. We have a support loop, and then we would slide the edge away from the support, actually away from the main edge, and we would still get our result. So it's fairly simple. It's also very effective, and basically you get the shape which you want. The thing is, the sliding actually again destroys this part right here. So in case for some reason you still need that, sliding might not be an option. So if we would talk about then what would proper topology look like without destroying this edge, I would just again, just quickly show my approach. So I would just add a one straight edge like so. So basically just trying to make it like this. Maybe it will work. And then basically we have a triangle here, but don't worry, simply because anyway, this is going to be removed. But these two edges now again are affecting the circle. So that just means that circle will not be 100% circle anymore. But the thing is, we can just redirect these edges here. and create a loop here. And then we have something like this. Then we're gonna need one more support on the outer side just to make sure that we don't have any stretching. And then basically we need to do the same thing on the sides. So I just want to create a straight line, let's say something like this. And I'm just using shift with the multi-cut, trying to snap, say here, looks straight enough. And yeah, so now we just need to connect actually this here, delete these two edges, connect this part, and just even it out. All right, so I should have maybe used symmetry, but we still can detach this, delete the half, and then we're gonna have symmetry on both sides. All right, so now what we need to do is just delete the inner parts. So like I mentioned, do not bother with the triangle here because we are deleting it anyway. And now we have this inner part. And the same thing as before, we just need a support loop, which is going to be this. And if we want to have it everything organized, we can also just delete one part. All right, and now we can just actually maybe see if this is fully straight, and we can just scale it like so. All right, so now what we need to do is just mirror everything back to its place. So mirror again, and this is going to be Z, I believe. And what we need to do now is just make sure that we have all of the edges like so. All right, and there we are. So as a final result, this might look okay, but if you want to have a more tighter corners, then there are again a couple of ways that you can do that. So as for first thing, I would just then start with more subdivisions. So instead of maybe 28, I would start with 32 and see how that works. Second thing is you can try and redirect some of the edges where maybe redirection is possible, because now we cannot just slide this point, this edge to this one, because again we're going to destroy the integrity of the circle. So in that case, yeah, we're gonna need probably to redirect some of the edges, and then we're gonna get something like this where the edge is going to look a bit tighter, but this area might be a bit tricky. Simply because we can add one edge here, which can sharpen it up, but there's not much really that we can do with this one. I mean, we can try, and I'm trying to select here everything. We can maybe try to add one edge loop here, and yeah, maybe do it like this, and then just delete these two. Push this one closer, and yeah, there we are. So I can also maybe now just push this down as well, and just mirror on Z-axis, and there we are. So a couple of solutions, we cover a couple of solutions, so for the tighter angles, for the smoother angles, and I think that should be fine for now. Let's just add thickness a bit here, something like this, and we are still missing some of the supportive edges here on the bottom as well, and on the outsides. And maybe we can also apply our blend material, and there we are. So hide the grid and just bring the project from before out, and there we are. So two examples. Cylinders, like I mentioned, they can always be tricky. It's just going to be dependent on really what you want to do. If you want to have a lot of details, you're going to need to balance that you do not start too dense, because that may also be hard to manipulate. a lot of edges is always going to be harder. So if you can start with the let's say smaller division level, something like maybe 20. I sometimes even start with 16 and then just subdivide it later if I need it for details. So this is just going to be trial and error, a lot of practice, and through experience you will notice where you can add more divisions, where not. Also, a lot of questions is about pinching on cylinders. So for example, in this area, the pinching is very, very minimal, and it's always going to be dependent from the distance from where the object is going to be shown. So if it's from, let's say, a larger distance, pinching really doesn't that matter. But if you want to do some close-up shots, then yeah, then you're probably going to need to have more divisions, and with more divisions, it's going to be always less pinching. So yeah, I think that this covers everything I wanted to talk about in this video. So yeah, thank you for watching, and I'll see you next time.